Hi guys, welcome to my most tutorials. We are looking at our final step on acids and bases. We are just looking at calculations involving titrations, right? Remember we said a titration, we are having a non-concentration, a non-volume, non-number of moles of one substance, and we want to find out for the other substance, right? To say we want to calculate for the other substance of the non-volume, okay? So for our example here, we are having just 30 cubic centimeters of 0.1 mole per cubic decimeter of sodium hydroxide, meaning we know the concentration of sodium hydroxide and we also know the volume of sodium hydroxide that we are going to react completely with 25 cubic centimeters of our sulfuric acid, right? And we are going to do this in a titration experiment. And the question wants us to calculate the concentration of sulfuric acid in moles per cubic decimeter. So what are we going to do? At first, you should be able to write a balanced equation between your sodium hydroxide and your sulfuric acid. So when we react sodium hydroxide and sulfuric acid, we get sodium sulfate and water. Remember, it's a neutralization reaction, right? So now balance it. Make sure you balance it. How do we balance an equation? So these tools, they were not there at the beginning, right? What did we have? We just had sodium hydroxide reacting with sulfuric acid to give us sodium sulfate and water. You then count to say, okay, on my left I'm having 1 sodium, but on my right now I'm having 2 sodiums. So what must I do? Let me multiply this 1 sodium by 2. So you put a big 2 here. But by so doing, this 2 is now going to affect the number of oxygens and hydrogens as well. It means now we are having 2 oxygens and 2 hydrogens. There we're just having H2O. So since now we are having 2 hydrogens plus another 2 hydrogens, making it 4. So we quickly came here on our right hand and we wrote a 2 there, knowing a 2 times H2 would actually give us 4 hydrogens. And for oxygens, we now have 2 here. 2 plus a 4, we're getting a 6. So we are having a 4 here plus a 2 there. That's a 6. Our sulfur, I'm sure you can see just 1 sulfur here and 1 sulfur there. That's a balanced equation. That's how you balance your equation. So step number 1. The question said, calculate the concentration of sulfuric acid in moles per cubic decimeter. So what do we know about concentration? Let's first find the reacting mole of sodium hydroxide. So for a number of moles, we say it's concentration times volume. And our volume, remember, it has to be in cubic decimeters. So 1 cubic decimeter is equal to 1,000 cubic centimeters. So that's why we are having a 0.03. Don't get surprised like, Memo, we're having a 30 cubic centimeters. Why are they writing 0.03? 0.03 because we have changed the cubic centimeters to cubic decimeters. So that was the first step to calculate the number of moles of what? Sodium hydroxide. After that, they said find the ratio of number of moles of sulfuric acid to number of moles of sodium hydroxide. So when we go to our equation that we've balanced, we can see that we have got 2 moles of sodium hydroxide reacting with 1 mole of sulfuric acid. So what's the ratio now? It's 1:2, which is half, right? That's the ratio. Step number 3. Use the ratio to find the number of moles of sulfuric acid that reacted, which is very easy. So on our answer there, when you multiply 0.1 times a 0.03, it gave us the number of moles for what? It gave us the number of moles for sodium hydroxide. So we are just dividing those number of moles of sodium hydroxide by what? By half, right? We are multiplying them by a half, or we're just dividing them by a 2. And what are we getting? 0.0015 moles. These are the number of moles of what? Of sulfuric acid. And then step number 4. Find the concentration of sulfuric acid in moles per cubic decimeter. So what is concentration? It moles over volume. The volume we were given, we know the volume, it was 25 cubic centimeters. So concentration now, we say moles over volume. So our number of moles, we calculated them and we got 0.0015. What's the volume? 0.025. Why 0.025? We converted our 25 cubic centimeters to cubic decimeters. That's why we are ending up with 0.0015 being divided by 0.025. Okay, you can punch that on your calculators to get the final solution. Those are the critical steps that one needs to follow to find the concentration of the other using titration. So that's very easy. Listen to the video as many times as possible for you to master this titration, right? It's actually very, very easy. Okay, this marks the end of our acids and bases, and our next topic that we're going to be looking at is the industrial processes, right? Starting off with the production of nitrogen and oxygen.